Okay, I would like to know the speed of a block sliding down a frictionless plane. I'm going to make the plane curved, and when I do that, that tells you it just screams energy. You need to use energy in order to do a problem like this. So over here, if I can fit it in, this is my initial height, and my velocity initial, or my speed initial, will be 0. So I'm going to use energy to do this problem. You need to start with the conservation of energy. Energy initial, well, that looks pretty bad. And I'm trying a different stylus right now. Energy initial, I don't like this stylus. So let me go back to the other one. And I don't like, oh, a little better. So energy initial equals energy final. And I stop and I take a look at this. So all the energy you could start with, when you first look at it, you could have potential energy, which is positional. You could have kinetic energy, which is from motion. And then when you look at it again, you could have potential energy again, and that'd be your potential energy final. And you could have kinetic energy again. Now, I need to go through, and if any of these things are not there, I need to get rid of them. So when the block first, before the block starts to slide, it only has potential energy. It's not moving, there's no kinetic energy. And at the bottom of the ramp, if I take that as my zero potential energy point, then there's no zero potential, or there's no potential energy. So I've got my initial potential energy equals my final kinetic energy. And now I can substitute how I can find those things. So potential energy, mass, gravity, my initial height. At the bottom of the ramp, my speed will be 1/2 mass velocity final, or I will get my kinetic energy from. I'm sorry. Now, both sides, you cross out the mass. I'm going to multiply both sides by 2. And then, in order to get rid of that square, I'm going to take the square root of both sides. And I will get the square root of 2g hi equals my final speed.